like an eternity ago, last year, ha ha ha, we covered chapter 3. Thank you, okay? You covered chapter 3, which seems like an eternity ago. And in chapter 3, we talked about graphing, finding slopes, finding y-intercepts, and graphing. And they have 2 sections in there, 3.7 and 3.8, in which they want us to solve systems of equations by graphing and by substitution. I just didn't know, we were kind of over chapter 3 because it's forever long. And so Mrs. Weiss and Mrs. Hoosier and I just decided, like, let's not do that right now. We'll come back to it. So we stuck it in today and this week because it's going to fit perfectly with the amount of time that we have in class. So what happens is we have 2 or more equations that have the same sets of variables, and they're called system of equations. When you have that, you have what's called a system of equations. Saturday. For example, y equals 4x and y equals 4x plus 2. 2 separate equations that both contain x and y. That is a system of equations. You can solve the system of equations. You can solve the system of equations by graphing the equations on the same coordinate plane. So before we were only graphing one line on a graph. Today we're going to graph multiple lines. The ordered pair for the point of intersection, or where the 2 lines cross, is the solution of the system of equations, because that point of intersection simultaneously satisfies both equations. Lots of big words there. Okay, the intersection, just like the intersection of a road, 2 roads is where they meet, and where they meet at the same time, simultaneously, that point satisfies both equations. Now I'm just going to give you a quick sketch of something, what that really means in a graph. So say I graph this line. Every single point on this line makes a true equation. When I plug in x and y, it makes it true. It satisfies that equation. Well, today I'm going to add to it that I'm going to graph another line. And every single point on the green line satisfies that equation. This point right here is technically on both lines. The point of intersection is on both lines. So that point is a solution. It satisfies both equations at the same time. So today we're going to graph 2 lines, and we're looking for their point of intersection. Okay? At the top of your page, let's remind ourselves the easiest way to graph y equals mx plus b. Slope, intercept. First thing we have to realize is y by itself. If y is by itself, m is your slope, b is your y-intercept. Okay? M is your slope, the number that is multiplied with x, and b is your y-intercept, or in other words, your starting point. All right, let's ease into this slowly. Let's look at number 1. Solve the system by graphing. Take our top equation. First thing I ask myself, is y by itself? Yes, it is. So y is by itself. Somebody tell me my slope. Ooh, that's an interesting looking M. Somebody tell me my y-intercept in that top equation. What is my slope? What is my y-intercept in that top equation? The y-intercept is absolutely -1. Good job. Somebody else tell me what my slope is. Next. Is it 0? What number is technically in front of here? A 1, a positive 1, right? And slope we always want to write as a fraction, so 1 over 1. Okay, so to graph this, we start with our y-intercept. Remember, your y-axis runs vertically. Your y-axis runs vertically. So we're going to put a point at -1, and that's my starting point. When I have a slope of 1 over 1, what directions do I need to go? Up and right. Up 1, right 1, put a dot. Up 1, right 1, put a dot. Miss Hoff always encourages, especially on paper, to put as many points on that graph as you can, because accuracy is going to impact your answer, how well you graph that line. Take your ruler, your straight edge, your book, and connect those dots, drawing the line all the way through the coordinate grid. Don't just stop at the dots, drawing it all the way through the coordinate grid. Put arrows on the ends. That line goes on and on and on and on. Good so far? Cool. Let's go to the next one. Yes, that's why you have your book. Use your book as your straight edge. Oh, use the binder part. Flip it. Yeah, use that part. Okay, take the second equation. Oh my God. First thing you check, is y by itself? Yes. What is my slope? What is my y-intercept? Y-intercept is -2, the number without a variable. Levi? Very good. Thank you for writing as a fraction. 2 over 1. Okay, so we're going to start at -2. So we go down to -2. There's my starting point. And Levi told us our slope is 2 over 1, which tells me to do what? Up 2, right 1. What happens when you go up 2, right 1? It crosses that other line, correct? Up 2, right 1, up 2, right 1. Now take your ruler, straight edge, book, whatever the case is. Connect those points. Whoopsies. Yours looks way better than me because Ms. Hoff can't use a ruler. But the whole point of this is we're hoping that they have a point of intersection. Do they have a point where they cross? Yes. Yes. Okay, now everybody think before you shout this answer. The answer you're going to give me is an x comma y. It's the point of intersection. What x comma y location do those two lines cross? 0, 1? Isaac? 1, 0 or 0, 1? 1, 0. 1, 0. Your brain's working backwards on you today, isn't it? 1, 0. 1 is my x, 0 is my y. Thoughts? Questions? Good so far? Okay, let's go to the one directly to the right. Y equals 4x. What's the first thing we ask ourselves? Is y by itself?
No.
Y equals 4x. Y is by itself. Okay, what's my slope? What's my y-intercept? Slope is 4 over 1. What's my y-intercept? What number could be written here that would not change the equation? 0. If there is not a number written there, it would be 0. So my starting point is 0. What's 0? The origin, 0, 0. Very good. 0, 0. So what does my slope tell me to do? Very good. Up 4, right 1. Now the downfall of that, there's only 1 point to have there, right? If instead of going up and to the right, what could you technically do?
Down and to the left.
Down and to the left as well. Again, your line should look way better than mine because I don't have a ruler. Now we have the equation y equals x plus 3. Is y by itself? Yes. What is my slope? 1 over 1. What is my y-intercept? 3. Where do you start? 3 on the y. Make sure you're starting on the y. Make sure you're starting on the y-axis. So I'm starting up here at 3. My slope tells me to go up 1, right 1, up 1, right 1. Good or bad? Good. Why do I ask you that? Intersects. We're looking for that point of intersection. Everybody on your own, without saying it out loud, tell me the x comma y location of the point where they cross. Tell me the x comma y location of the point that they cross. Who's got it for me? Is Taylor? 1 comma 4, agree or disagree? Agree, 1 comma 4. We talked about this morning, that sometimes we get confused which one's x and y. Think of it like your battleship game, right? If you go to 1 on your x and 4 on your y, and then where they meet, that should be your point of intersection. If you want 1 on the y and 4 on your x, they definitely don't cross there, just to make sure you choose the right point. Question?
In 5th grade, the teacher I had said that it's like moving a ladder. You don't go up before you move the ladder.
Oh, my father.
Yeah, I know.
Still tells me that. Every day? Don't climb the ladder before you move it, Micah.
Email me that.
So I should send him one that says, so I've heard. All right. Good? So what could be hard about this? They wouldn't intersect? Well, let's check it out. Skip 3, flip the page. Okay, so if I'm understanding this off correctly, all I got to do is graph 2 lines, write down the ordered pair. How can this be difficult? Let's go to number 4. Take the top equation first. Taylor's already seen it. Is y by itself? Yes, on the top one. What's my slope? 2 over 3. And my y-intercept is 3. Ah! Why is this scary? It's going by 2's. Watch your scale. Watch your scale. So how in the world do I plot a 3? In the middle, halfway between 2 and 4. Halfway between 2 and 4. Now here's where it's going to get a little tricky when we're counting here, right, for our slope. 1 is really half a box. Follow me? So if I need to go up 2, 1, 2, and then I need to go right 3. 1, 2, 3. I'm in the middle of a box. Very good. I'm in the middle of a box. Then if I do it again, 1, 2, 1, 2, 3. At least I'm on one line there, right? Everybody follow how you graph that with it going by 2's, because I'm going to tell you 3 of your graphs on your homework go by 2's. Connect your dots there. What's the question you always ask yourself right away? Is y by itself? And Taylor, you're going to already yell at me on this one and tell me it's not. What's stopping y from being by itself on the second equation? The 3. And 3 is multiplied by y. What's the opposite of multiplication? Division. Now here's the key though. When you divide this by 3, you have to divide everything, both the 2x and the 15 by 3. So when I do that, I end up with y equals 2/3 x plus 5 plus 5. Whew! At least our slope is a whole, or I mean our y-intercept's a whole number, right? My slope is 2/3. My y-intercept is 5. Where do I find 5 on my y-axis? In between 4 and 6. Okay, be cautious again here. We're going up 2. Count carefully. 1, 2, and then 1, 2, 3. Put a dot. 1, 2, 1, 2, 3. Connect them. Miss Hoff. Graph 2 lines, find the point of intersection. How do you know they're parallel? Okay, so this is what people always say, well, look at them, Miss Hoff. They look parallel. Well, the thing is like you could accidentally do this and they just not cross in the right spot. Okay? But to back up what you're saying is, look at your slopes. Your slopes between these two lines were identical, meaning they rise and run the same every time. They're never going to cross. What do you notice about their y-intercepts? They're different. So they started at different spots, but then continued to rise and run the same. So these lines absolutely are parallel. Okay, so the whole point of on the last two problems is I wrote down the x comma y of where they intersected. Well, where do these two lines intersect? They don't. So what's the solution here? Okay, so what's my solution? What's my answer then? They are parallel. They're not going to touch. They're not going to have any intersection. Okay? So what's my solution? There is none. AKA, no solution. No solution. There are no points that are on both of those lines because they never cross. They start at different spots and have the same slope. Okay, so that's not that bad, right? What other curveball can she throw us? Let's go to the next one. First question I ask myself, is y by itself? Y is not by itself. What's with it? A negative x. What's the opposite of a negative x? Okay, so to move it to the other side, I have to add x to the other side. Question. Can 1 and x be added together? Yes or no? Why not? Is there a 1 in front of the x? Like right here? Okay. So can I add 1 plus 1x together? Very good. So you just have 1 plus 1x. What's my slope? 1 over 1. What's my y-intercept? 1. Graph that point for me. Start at 1. Up 1, right 1, put a dot. Up 1, right 1, put a dot. My second equation here, y equals x minus 2 plus 3. First thing I ask myself, is y by itself? Then what's wrong with this equation? Yeah, what is this negative 2 plus 3? What are they doing here? What should we do? Put them together. They're like terms. I love your terminology there. They're like terms. Okay, don't let them fool you on this. Y is by itself, but what is negative 2 plus 3? Positive or negative? Positive 1. Your slope is 1 over 1. Your y-intercept is 1. Okay, so where do I start? At 1. How do I move? Say it, Levi. What were you going to say? I heard him say it's the same, right? Technically, when I plot those, I end up plotting exactly the same points. Look at your slope. What do you notice? They're the same slope. What do you notice about your y-intercepts? They're also the same. So technically when I graph this, the first line I graph, the second line when I graph it, graphs it right on top. Now the whole purpose of this was looking for a point of intersection. Those first two, we wrote down the one point they crossed. This one, they've said they didn't cross, so there's no solution. What's the answer to this one? Nice, infinite solutions. Every single point on that line, on the black line, is also on the blue line because they are identical. So infinite meaning never ending. Every single point you pick on one is going to be on the other. So you actually have three different results that you can get today. You could have one solution because those two lines cross and they meet at a point. You could have no solution because the lines are parallel, same slopes but different y-intercepts. Or you could have infinite solutions. They're the exact same line. It's only going to have one line look like it's graphed, and you're going to have the same slope and the same y-intercept. What if they wanted to just know, is there one solution, infinite solutions, or no solutions, and all they gave you were the equations of the lines? They don't really want you to graph. I'm going to modify number 6. What if I gave you the equation of 3x plus 2y equals 6 and y equals negative 1/2 x plus 5? Yep, 2y, yes, sorry. I give you these two equations, 3x plus 2y equals 6, y equals negative 1/2 x plus 5. And all I want to know is there no solution, one solution, or infinite solutions? To differentiate between those three answers, what do I need to look at? The slopes. Everything depends on the slopes and the y-intercepts. Okay? So if I take the equation on the left, 3x plus 2y equals 6. First question I ask myself, is y by itself? Okay, Isaac's out. What do I do to get y by itself? Taylor's out too because I know he's going to answer. No. I need to get y by itself. Max, first step. Subtract your 3x to the other side. 2y equals 6 minus 3x. Now, Levi, divide by 2. And divide everything by 2. You don't want a negative y. So if y is positive, leave it. Plus, if you would have subtracted 2y, then you would have had to subtract 6 to the other side. You would have had more steps, actually. So I really end up with y equals 3 minus 3/2 x. What's my slope? Careful. Not my slope. My slope is the one with the x. Negative 3 over 2. And my y-intercept is 3. On the other equation, is y by itself? Oh, thank God. My slope is negative 1/2. My y-intercept is 5. Somebody raise your hand and tell me, do I have one solution, no solution, or infinite solutions? One solution meaning those lines are going to cross and meet at a point. No solution, the lines are parallel and never going to touch. Or infinite solutions, when you graph them, they're going to graph to be the exact same line. Thinking? One solution. What's your backup? How are you going to prove to me that that's correct? Most importantly, the slope, right? The first thing we check is that slope. Are the slopes the same? No, that means they're going to cross. They are, and he's absolutely right. There is going to be one solution to this problem. They're going to cross. They're going to have an x comma y. I don't even care what it is. But they're going to cross because they have different y-intercepts. All right, let's summarize everything we just did. Lincoln just told us If they have different slopes, I don't even care what they have for y-intercepts. How many solutions do you have? One solution. They're going to cross. They have different slopes. Nobody cares about the y-intercept at that point. They're going to have one solution. If they have the same slope and different y-intercepts, their rise and run is the same, but they start at different points. There is no solution because they're parallel. And the last option we have, if they have the same slope and the same y-intercept, there is infinite solutions. It'll look like one line when you graph it. Some people say, Ms. Hoff, I graphed my two lines, like here's the x comma y. They graphed this line and they graphed this line. It looks like this. And like, oh, they don't cross. Well, off your graph they're going to, but that tells you that you probably made a mistake. Okay? If they're not going to cross, you have to prove to me that they're parallel. Show me that they have the same slope and different y-intercepts. I'm going to warn you. 3 of the first 4 problems, look at your scale, goes by 2s. So be cautious when you're graphing. Also, on this worksheet, on number 5, it's going to be the first problem on the back when I hand it out here. This needs to be a 3x plus y equals 3. Ms. Hoff screwed that up. Okay? Before you leave, I'll check the first couple of answers. Yes? As you're working, draw it. Ask your neighbor, is this what your line looks like? If they're not doing it for you, you absolutely can double check with one another, okay? But you keep your paper, they keep their paper. You're not telling each other how to do it, but you're just checking that your lines look the same. Cool? All right, I'll give you time to work here.